In the first lecture of radioactivity, we have discussed about the basic concept on radioactivity and different types of emission during radioactive process, for example, alpha, beta, gamma. In this lecture, we are going to discuss about the radioactivity law given by Rutherford and Svgi. So what is this law and what is the expression for this law? So if I consider that N is the number of nuclei or active nuclei, then dN by dt represents the rate of decay of nuclei at time t. So it is found or stated by Rutherford and Svgi that the rate of change of active nuclei is directly proportional to the number of nuclei present at that instant. And the negative sign represents here that the decay, that means the decreasing, the concentration or the amount of nuclei is decreasing. So that represents the negative sign. So we know that in order to remove a proportional sign, we need to bring a constant. So we write minus dN by dt is equal to lambda n, where lambda is the constant called the decay constant. So now if you separate this number concentration or number of active nuclei, so we write dN by n equal to minus lambda dt and integrate, we get log with base e n minus lambda t plus c. Now we have to calculate this integration constant by putting the initial or boundary conditions. So what is the boundary condition? At time t equal to 0, we consider that the number of nuclei present is n0. So if you substitute this condition here in this equation 2, so we get the value of integration constant as log base e n0. And if I substitute the value of c, that means the integration constant, back in equation 2, we can write down log with base e, log n with base e minus log n0 with base e, which we can write down as log n by n0 with base e equal to minus lambda t. And if we remove this log, we can write down as n by n0 exponential minus lambda t, where lambda is the decay constant and t is the given time. And finally, we can rearrange and write down n equal to n0 to the power lambda t, where n0 is the initial concentration or number of nuclei present starting, and n is that number of nuclei, active nuclei present at a given time t. So this is the decay law, which is represented as n equal to n0 e to the power of minus lambda t. Now what is half-life? Half-life, that means if I have a certain initial at time t equal to 0, n0 represents the initial concentration, initial number of nuclei, and this initial concentration or number of nuclei, after some time, if it reduces to half the amount, that means after some time t, say let us say capital Th, the concentration or the number of active nuclei reduces to n0 by 2, where n0 is the initial number of active nuclei, then this time Th is called the half-life. So if you substitute this condition in this equation, decay equation, we write that at time t equal to Th, that is half-life, the active nuclei or the number of nuclei is n0 by 2, which reduces to half of the initial concentration, and n0 remains n0. And if we calculate this, we get the half-life as t half is equal to ln2 by lambda, and which we write down as 0.693 by lambda, close to 0.7 by lambda. So half-life is equal to 0.7 by the decay constant. What is average or mean life? It is the average of age of all active nuclei present in the sample. So we define the sum of times of existence of all nuclei in a sample divided by the initial number of active nuclei in that sample, and if you substitute the value, we get the average life as 1 by decay constant or 1 by lambda. So this is about radioactivity. Thank you so much.